Okay, so in this video, I want to go ahead and talk about the tangent problem. But before we talk about this problem, I want to talk about this very simple idea, which is the idea of slope, right? So as we all know, slope is calculated by using this formula here, which is slope equals to rise over run, right? And rise is just a change in the y values and run is just a change in the x values, right? So let's look at an example here that I have on the board. So in this example, there is a person who is saving a certain amount of money each month, and this person starts with $500 and each month saves a certain amount of money, and so after 6 months this person has $3,000, right? And after 4 months this person has $2,000 and so on and so forth, right? So on the x-axis I have the number of months that have passed since this person started saving money, right? On the y-axis, I have the amount of money that this person has saved up, and this is in dollars. Okay, so this graph depicts a situation where a person starts with $500 and saves some money every month. Now the question is, how much money does the person save each month? To answer this question, we can use the slope, right? Okay. Let's go ahead and use our formula for slope to find the slope of the straight line, and that number is going to tell us how much money this person needs to save up for this situation to be true, right? Okay. So to find the slope, we need 2 points. That's important. We need 2 points on the graph, and in this case, I can choose any 2 points. Doesn't matter. But in this case, I've chosen this red point and I've chosen this blue point. And either of these 2 points could be my first point, and either of these could be my second point, right? In this case, I went ahead and selected my red point to be my second point, and selected my blue point to be my first point. Okay. So it says y2 minus y1, right? So y2 is just the y coordinate of my second point. And in this case, the y coordinate of my second point is 3,000, right? Okay, so I write that down here. So 3,000, and then I subtract it with y1. So what is y1? Y1 is just the y coordinate of my first point, right? And that is $2,000 in this case, right? Okay. And then I divide it by x2 minus x1. So x2 is just the x value, the x coordinate of my second point, which in this case is 6. There I have 6, and subtracted with the x1, right? So x1 is just my x value of my first point, right? The x coordinate of my first point, and that in this case is 4. So 6 minus 4, that's what I have here. And when I simplify this, I get 500. So this tells me that the person needs to save $500 per month in order to make sure that this situation happens, right? That after 6 months have passed, this person has $3,000 saved up, right? And so on and so forth. Okay, so that was a very simple idea, right? The idea of slope. Okay, so in our previous example, we had a straight line, right? And to calculate the slope of a straight line, when you graph an equation and when we get a straight line, we call that kind of a graph a linear graph, right? However, when we graph something and we get a curved line, then in that situation we call that a non-linear graph, right? So in this case, I have a non-linear thing. It's not a straight line. Now I want to try and go ahead and find the slope of this curve. There's a problem, right? The problem is this. On a straight line, the slope remains the same on the entire line. So I could have chosen any 2 points on that line, and I could have calculated the slope using those 2 points, and I would have still got the same value for slope. The problem is, on a curve, the slope changes from one point to the next, right? So here at the blue point, the slope is not the same as at the red point. So that's what I've written here. Okay, so now the question is, how do I find the slope of a curve like this? And that's where the tangent problem comes in, right? And so the problem is, how do we find the slope of the tangent line? Okay, so here I have my blue point, here I have my red point, right? And the problem is, both of these points have different slopes. What I can do is that I can go ahead and make a line a line that's called the tangent line, which touches this graph only at this point, only at the red point. And a line like that is called the tangent line, right? So I can go ahead and draw a line like this, and if I can successfully draw a line like this, then the slope of this tangent line is going to be the same as the slope of this red point. So if I can successfully find the slope of this tangent line, I will be able to find the slope of this graph at the red point. Now the question is, how do I find the slope of my tangent line? And I can do the same thing here, right? I can make a tangent line which just touches this blue point at only, which touches this graph only at this blue point, right? So I can make a line like this, and then I can go ahead and try to find the slope of that tangent line, and the slope of that tangent line is going to be the same as the slope of this graph at the blue point, right? Because as we know, the slope of this graph changes from point to point, right? It's not a constant. Okay, it's not the same. Okay, so the idea here is to first of all draw something out there which is called the secant line. Now secant is a line that touches that cuts the graph at 2 points, right? So I could draw a line that includes both of these points, the way I've drawn here, this orange line here, right? So this is a secant line, and it touches both of these points, the blue point and the red point. Now I can easily find the slope of this secant line, right, by using my previous formula of rise over run. Why? Because now I know my 2 points. I have the red point, I have my blue point, and both of those points lie on this orange line, right, on the secant line. That's possible. So I can go ahead and do that. So let me go ahead and do that. So the slope of the secant line is just 2000 minus 1000, because you know the difference in y values is 2000 minus 1000, and the difference in x values is 8 minus 5, right? And that's going to give me 1000 divided by 3. That's not exactly helpful, because that's not the slope of that could be roughly a slope of this graph, but not exactly, right? Because the slope of this graph changes from point to point, right? Okay. But the idea here is that we can kind of bring this orange line closer and closer to this red point, right? So we can bring this blue point closer and closer to this red point until this orange line becomes our purple line, right? So we can go ahead and continue doing that. However, the problem is, the more accurately we're able to do that, the more closer and closer we get to the tangent line, we have a problem there, right? Because then the difference in the y values is going to get to 0, and the difference in x values is also going to go to 0, right? And that's what the tangent problem is. As soon as we think we found the slope of the tangent line, we come up with this problem, right? So as we get closer and closer to finding the slope of the tangent line, we get change in y over change in x, which is 0 over 0. And the problem here is division by 0 is undefined, right? So we can't divide any number by 0 in math. And that is the tangent problem. Okay.